Thank you for joining me over lunch here. We're going to talk a bit about desktop frameworks in .NET. So we'll start with a very brief history lesson. So Microsoft back in '91 released a thing that was called VB, Visual Basic, which was an interesting idea because you could use a very visual way to create applications for back then still pretty new Windows. Then in 2002, they came with WinForms, which was basically the same Visual Basic editor, but upgraded to work in .NET. Then in 2006, WPF came along, which was a successor to WinForms. Then in 2012, WinRT came along. WinRT was the framework to build Windows 8 applications, right? We all remember that one. It was to be the successor to WPF. Then in 2015, UWP came out, which was to be the successor of WPF. And then in 2021, WinUI came out, which is the new successor to WPF. So who has used one of these? Who is still using one of these? Yes, that's what I thought. WinForms? WPF? WinRT? Good. Someone doing UWP still? One lucky guy. Someone doing WinUI? No one. So that's why you're all here. Okay, WinUI is part of the Windows App SDK, and that's why I wanted to start with this small history lesson. So we don't talk about WinRT anymore. It doesn't exist. But all of these are targets for the Windows App SDK. And that's what we'll be discussing in this session. A larger part will be about WinUI, but we are also focusing on the older technologies. So my name is Nico. I'm an application architect from Belgium, working at a consultancy company. I'm a Microsoft MVP in developer technologies for almost 10 years now. I run a local user group called VISUG, which stands for Visual Studio User Group. A lot of fun. I wrote a book on .NET 6. I will be trying to sell it to you a bit later in this conversation. And then some other stuff about me. And you can find me on Twitter with my name. So if you have any questions, you can always reach out to me there. I'm also on Mastodon. It's not here yet. But it's the same name at .NET.social. So agenda for today. We've done the history of frameworks. So that one's checked. We're going to see what the Windows App SDK is actually about. We'll start with that one. What's in there? What is it? And why should you care? Then we'll dive into some WinUI stuff. We'll also handle deployment and packaging of applications. That's always an interesting one. And then hopefully we'll have some time for questions. Right? No questions so far? Good. So the Windows App SDK, what's in there? It's a set of tools, different components, and it's mostly derived from UWP. UWP was a very modern framework with some really good ideas, also some really crappy ones, hence the state it's in right now. But they've taken out those good ideas and those components, those controls, and they've packaged that into a new SDK. And then these are bullet points coming from the Microsoft website. So that's why it's the next evolution in Windows app development. This is not the new Windows SDK, and that's important to know. You have the Windows SDK, the Windows App SDK sits on top. It's an extension, extra stuff to use. And this is one of the most important things in the SDK. It brings a unified API. You can use the same API calls, let's say, to handle notifications in Windows. You can use the exact same code all the way from WinForms to WinUI. The same calls, the same API. No longer need to know one specific framework, but you can use it across all those we've seen in the first slides. This is completely decoupled from Windows. So I just mentioned the Windows SDK, which we all use and sometimes love. Every time they find a bug in the Windows SDK and that needs to be fixed, or they want to add new features to it, there has to be a Windows update to get it to us as developers, to the users, and so on. This one's completely decoupled. It's on NuGet. They can update it out of band with Windows, which is a great benefit because they can move much faster. Just mentioned this. So this is the NuGet package. We're currently on version 1.2, 1.3 is in preview. Next to NuGet, you can also, that was the wrong button, use the Visual Studio installer to install some templates. And I'll be using one of those in a minute. That's mostly for the WinUI stuff. And then there's the components. What's in there? WinUI, WinUI 3. What is WinUI? WinUI was the idea of we have this great new modern toolkit, UWP. Some really great modern controls in there. Let's take those controls out, pack them in a NuGet package, and ship them to whoever wants to use them, out of bandwidth windows. That was the idea of WinUI. WinUI 3 is the first iteration where they're getting there. It's fun. It's fun to use. Then you have the dWrite core tool, which gives a more modern way of rendering clear type fonts. So you have sharper text. MRT core is also one of the things coming over from UWP. It's resources, translations. UWP had a new format of doing resource files. It was no longer resx, but it was resw. And that's coming over to the Windows App SDK as well, with possibilities to fall back to a resx. So if you have existing applications with translations, localization, don't worry. You can still implement the Windows App SDK and fall back to those legacy ones while you slowly upgrade to the newer ones. There's app instancing, which means control over how many instances of your application can be opened at once. You can limit this to one instance. If the user clicks the shortcut again, it just reactivates, or it opens a new instance and they can communicate with each other. There's rich activation, which means opening your application from a certain file extension or through a protocol. There's power management, having control over how much power am I using on battery-powered devices. What can I do to limit the power usage as soon as it reaches a certain level, stuff like that. We finally have control over windows. Yeah, you mean your application window, right? We can resize it. We can move it somewhere on the screen. We can do different stuff with it. This all might seem like logically in there, but do remember that this is a continuation on WinUI, and WinUI could not do this stuff. Of course, in WPF, WinForms, this is all basic stuff that's out there, but we can now do it here as well. Push notifications has been greatly improved in App SDK 1.2, the most recent version, where before you need to build an entire XML payload. Ever done that? It's an entire XML thing with the title element, the body element, icons. It was this for small notification. Now you can do it through a notification builder, just all in code, which is way easier and has IntelliSense. And then for deployment, there's a whole new installer option with MSIX, packaging, deploying. We'll dive into that more towards the end of this session. Most recent release is Windows App SDK 1.2. What's new in this? Are you all on Windows 11? Most of you? Some? So Windows 11 has widgets. Most Windows 11 users don't know or use this, but it's there. You can use it. And with the new Windows App SDK, you can build widgets to be in your Windows 11 environment. The only downside for now is it's only in C++. If you want to write your own widget for your application, like dashboard or graphs or anything, you have to do it in C++ for now. No timeline on when it will be upgraded or C# will be supported. Trimming is there, so we can minimize our application package, trim out the stuff we're not using. There's better support for HDR, ACM. ACM is auto color management. So you have the display information APIs in .NET that gives you the information of the attached displays on the device. Those are now extended with HDR and color management support. WinUI 3 got a bunch of new controls. There's now a media player element, media player controls, so we can actually embed videos and have control over whether or not they should autoplay, volume, and stuff like that. App Notification Builder I just mentioned. That's the XML replacement with all the Fluent API stuff. And we have custom title bars. Now, custom title bars are not new. They were there in previous version of the Windows App SDK as well. And what they do is, you all know the title bar. Before you could only set text in there, like a title. Now you can use Unicode, you can put controls in there, you can completely override it with your own XAML element. But up until now, this was only supported on Windows 11. Starting from version 1.2, it goes down level to Windows 10 October update, if I'm not mistaken. I should check. Some Windows 10 version also supports it now. And then there's WinUI. WinUI is the new desktop framework included in the Windows App SDK. It's new templates. It's a new template in Visual Studio. You create a new WinUI project. It has the Windows App SDK in there. It's bootstrapped, everything. It starts from .NET 6 up. WinUI 3 can be installed side by side with WinUI 2. What's the difference? It's more decoupled from Windows. WinUI 2 still had some tight coupling into the Windows SDK. WinUI 3 is less tightly coupled. Still not completely there, but mostly. All right, enough talk. Let's see what we can show you. For starters, let's start a new project. Let me zoom in a bit. WinUI. So I have installed WinUI through the Visual Studio installer, like I showed you. And then you get these templates. Couple of times the same template, but every time with different languages like C++, C#. This is a blank application packaged. That means that if you create or if you use this template, you will get an application, WinUI, XAML, C#, completely prepared to package as an MSIX application and ready to either sideload or push to the Microsoft Store. Then there's this one, which is similar, but the entire packaging thing is a separate project. We'll get a bit more into detail later, but if you package your app or not, it has an impact on what you can do, on the permissions that you have. Doing it with a separate package means that you can still run your application unpackaged as well, which gives you a bit more permissions. For now, we're gonna go with packaged. There should be a folder here called Swedish. We'll give it the name app1, sounds good. And let it create. Most of you have ever done WPF or WinRT, UWP will recognize most of these things. It's your basic XAML-based Windows application. You have an app.xaml, which is your entry point. There's the main window, which is your first window that will open with some controls there. And this package.appx manifest, that's with the MSIX packaging. That's what declares everything that needs to go in your package. Let's have a quick look at that one. So for example, and I have a demo later on showing this, in your declarations, you can use things like, I want my app to respond to a certain file type. If I have my own file extension, you can declare it here. If your app is installed through the MSIX installer, then and you double click a file, it will open your application. For example, you can set icons in the visual assets. There's a bunch of application stuff. You can add your name, your supported orientations. Nothing new. I forgot to increase my font size. Let me quickly do that. There we go. And now if I open a file, you should be able to read it. Is that big enough? People in the back? Yeah? All right. So just to prove that the Windows App SDK is in there, let's go to the NuGet packages. Install packages is the Microsoft Windows App SDK. If you are using these templates, do check if there are newer versions available of the NuGet package. Like there is right now, minor version is available. Okay, let's have a look at the translation thing. MRT. Can I find the app itself? No. Okay, so this the next couple of demos are all taken from Microsoft themselves. These are open source demos out there on GitHub, and they each show you one specific element of Windows App SDK, one component, one API. So this one's about the translations that I just mentioned. As soon as it starts, it will show an application with different buttons. It will get translations from a normal ResW file, normal resources file. It will fetch one from a resources file in a class library, which is also an option. And it will fall back to a legacy file as well. So this is the application. If I click default language, we get an English text here. We can override it to go to German. We can fall back to the classic legacy format, or we can fetch it from the class library. A very exciting demo. Looking at the solution, this is the application itself. This is the package project. So this is set as a starter project, which means we are running it in a packaged, containerized environment. So don't worry about that one for now. These are the two new languages or resource files. There's the English one, English US. There's the German one. This is the classic legacy one. And then up here is one set in a class library. So going to the code. Firstly, we need a resource loader and a resource manager. And these are the APIs coming from the Windows App SDK. And using this, we can add some languages, and then we use the resource loader to get a specific string called sample string. If I open the resource file, this is the key that it's fetching right now. Nothing special. If we override it, we can use a resource context to specify which resource we want. And that one is set in the constructor up here to German. So if we pass in that resource context in the call to the resource manager, it will try to see if it has a German language in there and fetch the string from there. For the fallback, we try to fetch the string in a very similar way as the first one, as the classic one. But if you look at the app entry points, the app.xaml, there is an event called resource not found on the resource manager. So the resource manager is shared across Windows App SDK. It's a singleton. If the resource not found event is fired, then we use the legacy resources to see if it's in the legacy file over there. And we do it that way. Okay, up next. Activation. So this is the project that's currently opening in the background. I have two files with a file extension called foo. If I open one of them, the application starts. This is the application that's currently opening in Visual Studio. In a WinUI project, if you launch an application from within Visual Studio, it gets installed on your machine. And you can just launch it from the start menu without having to open the code and run from within Visual Studio. Similar to what UWP used to do. Okay, again, very exciting application. If we request the activation info, you can see that it was launched through a file because I double-clicked the file. And the file name is also in there. If I just open it, then activation kind is just launch. So we can get this from code. So to do this, you can get the activation info, and there's a kind enumerator in there. And based on whatever kind of activation has happened, you can get more information. If it's a normal launch, you can get arguments if it's launched from a command line or anything. If it's through the file, you can get the file name here. We can also launch through a protocol. For example, if I open a run window and I use this like you would open a URL, http :// but then with foo, my application once again opens and I get activation kind protocol, which is a neat little trick, especially, for example, if you have a website. Then you've seen these messages, right? A website tries to open your application. And then you can pass in specific arguments from your application to your website, which is a nice little interaction between your two platforms. Next one is instancing. Pretty similar demo. Let me just close all these. Instancing is about whether or not an application can have multiple instances open. If I go here, instead of foo, this is moo. Very similar application. Activation kind is file again. It's the file name is there, but now we also have a registered key. This instance of my application has a key. I've set the key to be the file name, so just to know if we should resume or open a new one. If I open the same file again, it reactivates this instance. No new instance opens. If I open the other one, we get a new instance of the application and an extra key registered. And iTunes has an update. So to do this, we have to be in two places, the app.xaml.cs and then the program.cs. So again, this is where we capture the activation kinds. We try to see if there is a current instance. If there's not, that means we have no registered keys yet, so we just fire up a new one. Getting into this if block just means the application was not opened yet. Start a new instance. This is where we can decide if we want to redirect to an existing instance or create a new one. To do that, we can get from app instance, the current instance. We can check what its activation kind was, because we want to match that one as well. If it's a file, then we try to see if the key that we are building now, the file name, if that key is already registered. If not, we register it now and we create a new instance. Okay, on to the final one, I believe. I think I have to, there it is, with the Ninja Cat icon. Windowing. I've mentioned this in the slides just now. We can completely take control over the title bar. We can take control over the window. For example, we can set the window to be the classic 640 by 480, and it resizes. Also notice how everything neatly just reshapes into still a very visible, usable application. That's also quite easy to do with a more modern XAML. full screen again. This is now my basic classic title bar. If I set a Windows title, you'll see that it supports Unicode now. But we can take it one step further. We can color it or we can make it fully custom. The title bar you're seeing now, let's just zoom out for a bit. This is not the default title bar that the window element in Windows has. This is my own XAML element. This is a XAML grid that you're seeing now. Which also means if you want to be able to do this, you have to define the draggable area on that title bar, because otherwise you won't be able to move your window around. And then you can set different heights or reset it back. Then there's the presenters, which are different views of your same application. And you've seen this before. For example, on YouTube, if you're playing a video and you go back to the overview, your video keeps playing in the corner. Facebook does it as well. That's what this is. It's a compact overlay. Let's go back to default. We can also do full screen if you want to build kiosk applications. You can go to full screen modes. It's still possible to exit. And then we get control over the drawing order as well, the Z order of the applications. Going into the codes. First thing we need, where is it? Is some extension methods to fetch the window handle. We need the window to be able to do stuff with it. So these two extension methods, they get the handle for you. Well, this one does. Gets the instance of the application window, gives you the option to change the title bar, the position, the size. Let's start with the presenters, for example. So there are a couple of presenters, the compact overlay, full screen. Are there others? No, that's them. If you want to change them, the main app window, which is fetched through the extension method I've just shown, has an option called, or a method called setPresenter. There's a list of possible presenters. You just pass in which one you want, and the platform does the rest. Going to the title bar, which is a bit more complex. So your main app window has title bar properties. You can use them all to set foreground, background, change all the colors, reset it back to the default. If you want a complete custom one, it should be in here somewhere. You can set the title bar visibility. No, this is my element. You can set your own element's visibility to visible. You're hiding the title bar. Of course, the first thing you need to do is check, can I change my title bar? Because as I mentioned, it's not possible across all Windows 10 and Windows 11 versions. So they have this method, is customization supported? Up until now, it would only return true on Windows 11. Now it also does on specific Windows 10 versions. And then, of course, you need to set the drag region for your custom title bar. Okay, these were some examples of built-in components that you can use through the Windows App SDK. If we jump back to our WinUI project that we created, we can start writing some code. I'll just make a really simple demo with a text that has a binding to a counter. Let's put this vertical. There we go. So your basic counter demo, you've all seen this hundreds of times. What should happen is if I click the button, the counter increases. We, of course, have to define the counter element. Through the magic of ReSharper, this will be a bit faster. I implement iNotify property changed on my window. Add a counter property. Change it to a full property with change notification. And we're done, right? So, question to the WPF people. What am I missing? This will not work. Why not? Ooh. Let me prove you that that doesn't work. So I have my counter, I have my binding. I'm missing one thing. There's that, of course, as well. That was just me forgetting it. This is the button event handler. There we go. We have no data context. So you don't see a 0 appearing because integer by default is 0. There's nothing counting up. We have no data context. Okay, no problem. We are used to, or we used to be able to set the data context on the window, right? Looking at my IntelliSense, there is no data context on window anymore. We are still inheriting from the base class window, but in WinUI, a window is no longer a framework element. In WPF it was just a normal control. Not so in WinUI, because the window is more than one of the XAML is more than one of the XAML elements that's being rendered inside. It mostly works on pages, the entire WinUI framework. And for the windowing, they needed to create a more native control, so it's not a framework element. That's why we can't set a data context to it. There are ways around this, of course. Let's say, for example, there's the My button. That still has a data context. So any element that you define in your page still has a data context. You can just name your root element, your root grid, and set the data context to that one. That would definitely work. But what you can also do, and I'll just zoom in for a more dramatic effect. Instead of a binding, you can use XBind. XBind was introduced in UWP and is a new form of binding. It's compiled bindings. So the compiler takes this binding statement and instead of interpreting it runtime, like it used to do with the classic bindings, it will change this into a C# statement that says this text block, which gets a unique name, .text equals counter value. That's what it will do. Big added advantage. If I make a typo and I try to compile the application, I actually get compiler errors. There we go. Property not found on type main window. I don't need to set a data context for XBind because the only data context it can have is its own code behind. So if you're doing like an MVVM scenario, you need to add a member in your code behind that goes to the view model. It's kind of breaking the pattern a bit because you're tightly coupling your view to your view model, but it's the only way that you can do it. Okay, let's run it again. Sure. Sorry, does it what? Does XBind require on property changed? Yes, it still does. Okay, so my integer value is showing, but if I click the button, nothing happens. This is one of the biggest changes when you compare XBind to binding. The binding mode is always one time by default, no matter your element, always. So if I change the modes to one way, then everything should be up and running. And this is a really stupid simple demo, so you won't notice a big difference when you compare XBind to binding. But if you have these really complex pages with a lot of binding statements on them, you will notice a great difference. You will also, if you ever convert a complex page from binding to XBind, you will run into problems. It's a promise. But they're all solvable, and it's worth it in the end. The performance difference is big. Well, let's see what else. I promised you I would show you some old stuff as well. So if some of you ever saw other sessions of me before, you might recognize this application. This is an old WinForms application. It was built using .NET Framework 4. It was afterwards converted to .NET Core 3, then to .NET 5, .NET 6, .NET 7. It's on .NET 7 now, as you can see here. But it's classic WinForms. So what this application does, it's your basic WinForms thing. It allows you to select any image. Do I have an image somewhere? Probably. Where did I use this? Oh wait, I know. Let's just take an image of me. So what it does is it pixelizes your images. The reason this exists is because we had at the office once a post-it war. It was the Java unit versus .NET unit. We just made images in post-its. And we won, and they never figured out why. This was our secret weapon. So basic WinForms application upgraded all the way to .NET 7. Now, why am I showing this? Because I have this extra form here that hosts a web view. This is the basic web view of WinForms. And it loads the html5test.com website, which figures out how compliant to HTML5 your browser is. Now, the web view scores 308 out of 555 points. It also claims I'm running IE 11 on Windows 8. I can assure you this is Windows 11. That's because the web view in the WinForms toolbox is still based on IE 11. That's why this website is saying this. Now, okay, I'm using an older framework, I agree, but I've upgraded to .NET 7. There's this thing called the Windows App SDK. Maybe I can use it to modernize this form. So what I can do is add a NuGet package, which is called the WebView 2. The WebView 2 NuGet package is released by Microsoft. Now, this is not the Windows App SDK, I agree, but it is part, or it uses part of WinUI 3. It uses a technology called XAML Islands. And what XAML Islands does is it takes modern controls, like the web view in UWP or in WinUI. That web view is based on the Edge browser, and it allows you to host that XAML-based control in your WinForms or WPF application using the XAML Islands interop. So I install this, open the WebView form, there we go. This is the old WebView. Let's delete it. And if I go into the toolbox, then the WebView 2 control is there. Drag it in, resize it a bit, pull up the properties, go to the source. So this is the WebView. Where's the source? Here it is. So we're not only just rendering the elements in an old application, we have access to the complete properties in developer experience that we're used to. There it is, html5test.com. Just have to make a quick detour to the code behind, remove this, and run it. So I've done nothing spectacular. I added a NuGet package, I dropped a new control on my form, added a property, and now if I launch the demo, it renders the new edge control. It still says Windows 10, but okay, close enough. That's actually because if you look at the version of Windows 11, like the actual build version, it's still Windows 10. It's basically an update on Windows 10. So the user agent is the same as well. All right, let's jump back to the slides for a moment. Okay, so we've built or optimized our application using the Windows App SDK. Great fun. Now we need to deploy the thing. We can deploy when deploying or packaging Windows App SDK application, we have several options. We can do it in a framework dependent way, which means that if you install the application on a user's machine, you need to make sure that the version of .NET that you're targeting is installed on that machine. But we can also do it completely self-contained. That means that you're packaging the whole thing in one installer, the full .NET framework, or at least the parts that you're using. The Windows App SDK, it's all there, one big package. Doesn't matter what's running on the user's machine, you just ship all the binaries you need. Sounds great. Does increase your installer size, of course, but it also means that it's up to you to patch any vulnerabilities that are discovered in .NET. So that's definitely something to keep in mind. Installer options. Who's used one of these? See a lot of nodding. All of these are replaced is a big word, but are now MSIX. MSIX is a new installer format. So we have too much installers, let's create a new one, something like that. The big advantage of MSIX is it runs containerized. If you install an MSIX application, it actually launches a small container with a virtualized registry, a virtualized file system. Your application runs inside that, completely self-contained. If you uninstall this application, or let's take a step back, if you uninstall a classic application, what happens? Registry keys gets left behind, files, cache get left behind, computer starts running slower and slower and slower, and you have to reinstall Windows or reset Windows every 1 year, 1.5 years, because the damn thing won't work anymore, right? That's called machine rot. And if you switch to MSIX, due to its containerization, virtualization, it just removes everything, no traces left behind. So that's a big advantage. It also means if you update your application to a newer version, the update will be differential. Only the bits and pieces that have changed get downloaded. And you can update automatically. And this really looks like, what's it called again in WPF? Click once? It's similar to that. If you want to distribute your MSIX application, you can go through the Microsoft Store, just push it on there. There used to be a time where you could only push UWP applications to the Microsoft Store. Not anymore, you can do anything. Notepad++ is on there, Paint.NET is on there, they're not UWP applications. It's Win32. You just need to package them, that's all. You can put it on any file share, HTTPS endpoint, or basically anywhere. As long as your users can find it, they can download and install it. Now for packaging, you have 3 different options. If you do the full MSIX packaging, then your application gets a package identity. And the identity is what you need to, for example, to do the notifications thing, or To add like the right-click pop-up menus on your taskbar. Like for example with Word that shows your most recent files. If you want to do that, then you also need a package identity. And there's some more stuff in the list. You can, if you already have your own installer, for example, MSI or setup. Whatever, you can package it with an external location, which means that your application gets packaged using MSIX technology. You get your package identity to access all the APIs, but underlying it still uses your own installer. If you double click the file, your installer will pop up to install it. So it's a bit best of both worlds. Or you can just say, I don't need no package identity, I'll write my own installer. That's still an option as well. There are some limits if you are doing MSIX. For example, you can't do any Windows services, not supported in MSIX. Communication between processes are very limited. You can't start your application using administrator rights if you install it through the Microsoft Store. File access, registry access is severely limited because it's virtualized. There is no access to the actual registry. And your enterprise administrators can disable updates through the Microsoft Store. So your policies might fight you here as well. All right, couple of minutes left for a quick demo. Going back to the pixelator thing. Let's say we want to package this WinForms application up as an MSIX. So we can add a new project to the solution. We look for installer. No, we look for MSIX then. There we go. And we have a Windows application packaging project. In order for this to show up, you need to install the Universal Windows Application Workload in Visual Studio. If you're not seeing this in your template, you're missing that workload. Next, and create. Oh, it asks me what version I want. Minimum version, Windows 11. Maximum version, the most recent Windows 11. There we go. So now we have our manifest file. You remember the one that was included in the WinUI project itself? We now have it here in our installer project. We need to add a project reference to our WinForms application. Now it's in here. We set this as the entry point. We set this as the startup project. And now we're fully an MSIX-based packaged application with a package identity. If you want to wrap this up into our package and ship it, then we can go to publish, create app packages. We can select if we want to go to the store or we want to do side loading. So side loading is basically everything that's not the store. We can enable automatic updates. Going through the wizard, we can actually create a certificate. So all these packages are signed, right? So you can have your own certificates to sign it from Azure, from the store, wherever. Or you can create a self-signed certificate, which is really easy. You can just click the trust button and it's added to your key store on your computer as well. You can add a version, set whatever CPU you want, or whatever configuration you want. Here it needs a path where it can check for updates, but you can add anything. There's no check if it really exists. My awesome share. Create, and now it's building the application, it's packaging everything up, which I've already have here to show you. Here. This is what it looks like. This is a package. There's some other stuff in here as well, and it gives you an HTML file which looks like this. So if you take the entire folder that just shown you, put it on an FTP somewhere, point people to this page, they can click get the app, and the wizard starts to install the application. All right. let's wrap this up in under a minute. So some takeaways. Windows App SDK is all about modern Windows APIs. You can use all the new things in your old legacy applications. That's basically the gist of it. It's completely out of band with Windows, so updates are not dependent on Windows updates. They can come by their own through NuGet. WinUI 3 is the biggest thing in there. It's a new UI framework based on UWP and is a successor to WPF. Don't forget. Through MSIX, we can do containerized deployment, which prevents machine rot and so on. Some interesting resources. The Microsoft docs on this thing are actually really good. So if you want to learn about the Windows App SDK, that's definitely the second best place to go. The best place to go is through my book. It's based on .NET 6. We're at 7, but there's an entire chapter in there on the Windows App SDK, which is still very valid. So buy it. Some references. This is the Microsoft Learn website, where you can follow tutorials all throughout the Windows App SDK. And with that, I'm afraid we no longer have room for questions. But if you have any questions, reach out to me through Twitter or come find me at the conference. I'm here all day. Thank you very much.